Hello, good evening, everyone. Good evening, Devashish. Good evening, Rakshita. Good evening, Prithvi. I'm good. How are you? Good evening, Sajla. Good evening, Jyoti. Good evening. Good evening, Arpan. Okay, so today I think it is last session for, good evening, Abhinraj. Last session for revision class for CBSE, right? Hopefully we'll do everything today. I think last class, okay, we did LPP. Yes, LPP is there today. Should I do LPP only first? I know that maximum, minima, and tangent normal is left out in.
Yes, sir, but LPP is, I think it's better.
Okay,
Like
let
only
me do
those.
LPP first, then we will do that also. Don't worry.
Yes, sir,
Right,
because
okay.
there are only like three types of questions, right? If we
Correct, correct.
start
We can finish it fast, right? Okay, so we'll do LPP first, and then after that, I'll revise, I'll do that part also, which is what left in applications of derivatives. Okay, so, okay, tell me, there are, okay, transportation problem is not there in the portion, I think. Is it there? Transportation, machine, diet, and all those are there. Hello, Varun. Any idea, anyone? Okay, let me check, no problem, right? Okay. But I don't think transportation is there, as I checked it last time, I think, right? Okay. Good evening, Aditya. Good evening. How are you? Okay. So first LPP is what? Okay. Linear programming problems, right? So in that what? I hope everyone knows already, right? How do we graph any inequality? We need to know that, right? Okay. Before doing this chapter, right? Okay. Before to do this, okay. To this chapter, we should know how do we graph the inequalities, right? So I hope everyone knows that. If you want me to explain graphing inequalities, right? Okay, we should know that. I'll just explain briefly, right? Okay. Suppose they say x plus y is greater than 5, something like this, right? Okay. So what I need to do in that case, first we'll graph, right? Okay. This line equal to, we'll consider that it is equal to, we will graph that line. So easiest way to graph any line is what, right? I'm going to graph x plus y is equals to 5, right? This line. Easiest way and best way is what? Don't take random points. We should take always what? X equals to 0, then what is y? So when x is 0, y is what? 5. 0 comma 5. And then when y is 0, x is what, right? Okay, so that is also coming 5 comma 0. So that this is what better way, right? Okay, whenever it is there like this, okay, we should take that. If suppose equation is something like this, x equals to y, in that case, so right? Okay, that or 2y or like that. So that time you can take different point, right? 0 comma 0 it will pass, and then some other point you can take, then you can graph it, right? Okay, because to graph any line we need minimum 2 points, right? So that way it is correct. So now this is what our line, right, whose graph is needed, right? Okay, this is what the line we have. This is what the point here, this is what this point, right? Okay, like this here. Now I should graph this inequality will divide the this whole plane into two parts, right? Okay, like this side and this side. Now which side? This inequality will represent this region or this region. How we need to verify that? Okay, to verify that, what we will do, we will just check, okay, any particular point we can substitute here and we'll check whether it is satisfying or not. Yeah, origin is best right here in this case, right? Origin if you put here, so it is not satisfying. Origin is not there in this solution, in the solution of this inequality, or no, part of this inequality. So we need to shade the other side region. That's it. Because if I put 0 comma 0, right, what it is showing that, okay, this side region is there, right? Okay, like that. But I would not say that, okay, like it is better to just give one arrow mark, right? Don't shade it fully. And then it becomes complicated to read sometime and all, okay, right? I know you need to do objective question only. So when we are putting 0,0, yes, what we are getting, guys, here, it is what greater than 5. 0 is not greater than 5. So that's why this side we should not shade, we should shade the other side, correct? That's what, yeah, which is false, right? Exactly. And guys, okay, it is always better to give just one arrow mark. No need to give so many, because we need to plot other inequalities also here. So it is what best way is what, okay, just point that this side region I have here for this inequality, right? Then you will have another inequality. Let's say that graph is coming something like this, right? And that is what here, then some other inequality, okay, like this here, that is here. So then common part, okay, this is what the part we are talking about, right? Okay, like that it will be there. Got it now? So the line should be dotted, right? Okay, because it is strictly inequality. Yeah, correct. Line could be dotted or exactly right. Okay, there are different types of correct. It could be dotted. You can make, or what you can do. What is the other thing could be there? Here you're making. You're not touching the line. Okay, like that it is. Means line is not part of the solution. You're just making arrows above it. Okay, like that you can say. Okay, like this also, or dotted line, anything is fine, because dotted line making is what sometimes difficult. So we can make it like this, not touching the line also, this side region, but not line part, because it is not 5. Okay, these are all points which are above than that, right? Okay, that's how it is. So this we should know already. Now after that, okay, to understand LPP, okay, what is the first thing we have? We need to have something called as objective function. Everyone knows that. One thing is there, okay, which is what? Objective function. What is our objective, right? Okay, so in terms of variables, in terms of like, okay, variables x and y, we'll have an objective function which we write like something like this. Z is equals to some constant a x plus b y, like that, right? Okay, so this is what we'll represent the objective like that. Okay, like we will be writing objective function this way, and then some constraints will be there, right? Constraints will be these inequalities, right? Constraints are going to be like something like, okay, a1x plus b1y is less than 0, or something like b1, correct? Like this we can have, right? Okay, objective function, different objective functions could be there. So I hope everyone knows that, right? This is what form like mathematical form of our linear programming problem, right? Where some paragraph will be given, from that we need to formulate it. Okay, this is what it is. To maximize or minimize, yes, we will get here to maximize it or minimize it, right? So I hope everyone is aware of that, right? Okay, everyone can do. Constraints, everyone understand, right? Okay, theory part is not needed. No, constraints are what? Linear inequalities through which we will be making different that region which is what bounded by those constraints, right? Everyone understand that. Objective function, you can see z is equals to this is what objective function. I'm not giving theory part, right? Okay, I'll come to the questions directly. Optimal value will be what? Maximize or minimize, right? Okay, at what constraint values, okay, we'll optimize that, okay, right? Okay, that is what it is. Feasible and infeasible region. What is feasible and infeasible region? Feasible region is what? Where all the constraints are meeting. Like I just took the example, no, suppose there is one constraint like that and one constraint, okay, like that. Okay, they are showing this side, this is what our feasible region, which is what satisfied by all the constraints, right? So what is feasible solution? Points within the feasible region, right? Okay, those are what? Feasible solutions, right? Okay, feasible solutions we have. Optimal feasible solution will be what? Any point in the feasible region that gives the optimal value, right? That is what final answer kind of, right? Okay, that is what it is. So this theory part, I don't think, okay, yeah, which satisfies it, right? Exactly, which is what maximizing or minimizing that. Okay, sometime it could be bounded and unbounded. I think we did in the regular classes. Okay, there was one exception case, right? Okay, in which we get unbound region, and there one condition we need to check. So I'll take that also. I think many of you might have difficulty in that part. Little bit confusion could be there, right? I'll take that example also, which we did, I think, in the regular classes, right, Jyoti? You remember? I think, right? We did in the
Sir.
when unbound region is there, right? That one.
Yes, sir. Then we just find for both objective functions and find the
Yeah.
maximum minima and then just plot the line there.
Yeah. Well, I'll take the example. Don't worry. Okay, right, guys. Okay. Others, I think it might be tricky at time. We'll see that. Okay, don't worry. Okay, so guys, one question is there. Everyone answer this. I think you all can answer it. Okay, but without any silly mistake. Okay, give me the answer. Z is equals to x plus 2y subjected to. Okay, they're saying minimize and maximize both. Minimize it and maximize also. Give me minimum answer and maximum answer both, right? Okay, maximum and minimum both. Maximize it and minimize it. Okay, like that it is there. Subjected to these constraints, x plus 2y greater than 100, greater than equal to 100. I'll also do parallelly so that if anyone didn't do this before, okay, he can get the clarity on this part. 2x plus y less than or equal to 200. And then x comma y both are, generally it will be this, right? Both we'll be doing for positive part only,
We'll
right?
only
Okay,
keep it in the first quadrant.
yes, we are going to, most of the time it will be first quadrant only. Constraint is same as objective function. Constraint is same as, yeah, it is same. X plus y is x plus 2y is greater than or equal to 100. 2x minus y is less than 0. 2x plus y is less than or equal to 200, and x comma y is what? Greater than 0. Both we need to do, right? Okay, maximize it and minimize it. Okay, do it, everyone. What should be the answer? What is the way for what values of x and y? It is maximum. For what values of x and y? It is minimum. Okay, I'm also doing it parallelly, but you do it. Okay, who all knows? Okay, you do it yourself. Okay, Jyoti. 1 second, we'll check that. So we will plot this first. Okay, right. Okay, I'm going to do this. So again, what I said, okay, like I'm going to take x as 0. So y as 0. So x will be 100, right? X will be 100. Okay, 100 is, let's say, this much. So 100 comma 0 it is. Then y is x is 0. So y will be 50, right? 50, this is 50. So here also 50 is this much, let's say. Right? So we will make this line. Now, which side should I shade? Okay, this side or above side? When I put 0 comma 0 here, it is what? 0 plus 2 times 0, it will not be less than, so above part. Okay, so I'm just giving one arrow mark like that. Now this one, 2x minus y, it is something like y equals to 2x only, right? Okay, means it is what? Some line like this. Y equals to x, so slope will be 45, but I'm making it y is equals to 2x kind of, right? Okay, now I should shade this side part or this side part. To decide that, what we'll do, if I put 0 comma 0, 0 comma 0 is not going to help us here, right? So what point we should put? We can put 100 comma 0 only, or some other point, right? Okay, 1 comma 0, right? Anything is fine, no? If I put 1 comma 0, 1 here and 0 here, so 1 comma 0 will not satisfy this, right?
Towards y-axis, towards positive y-axis.
Yes. So what we are getting here, this side part, or maybe like, okay, this side part, right? We'll see that, okay, because we have next condition. We'll see that, okay. Now here, It is 2x plus y. So when I put y is 0, x is becoming 100. So it is passing from this point only. Right. And then when x is 0, y is 200. Okay. So I need to make it a little bit more. Let's say it is what? This one. Like this, right? Okay, by the way, in subjective, you should give the line equation also here. When you're doing, okay, this roughly, it's fine. But when you're doing subjective, okay, should show like that, right? Okay, your teachers might cut marks for this, okay, that you're not giving what inequality you are, right? Giving, okay, they're making there. Now, if I put here 0, 0, it is what? Less than 200. So that's why this side. So as of now, by all these three, we are getting this region. Okay, that's it, right? Okay, this is what our feasible region, if you see. Now this point is what? Correct? Everyone is getting same or something different? Is everyone getting same? Laptop overcharging. Yeah. Thank you. Yes, feasible region is coming this only for everyone. This point is 0, 50. Now we need to calculate, we need to find out these points also. Right? These points as well, we need to find out. So this line and these two point of intersection we need to find out. So what is y equals to here? Y is what? 2x. So it will become 5y is equals to 100, right? So y is equals to 20, right? And x will be what? 40. So this point is what? 20, 40. Is everyone getting that? 20, 40 is the what? This point. You can name it if you want, right? A, B, C, and this is what D, let's say, right? C point coordinates will be what? We will solve what? Which two equations? Okay, this equation with what? This equation, right? Okay, these two. So we'll put again y is equals to 2x. So 4, we are getting 50. X is what? 50. And y will be what, guys? X is what? 50. So y will be 100, right? So C point coordinates are what? 50, 100. That's it, right? Okay, we got all the points. So we have, I hope everyone is getting same, right? Okay, just to verify, okay, like this here, Z. Then we have points, okay, what? 0, 50. Then, okay. Z is what actually? X plus 2y. So when we have 0, 50, what is the value? Z value, right? Okay. What it is coming? 0, 100. Yeah. Then for this is what A point. B point, what is the value? 20, 40. So what is the value we're going to get?
100.
100 again. Yeah. Then what? C point is what? 50, 100. So what is the value we are getting there? 50 here.
250.
Yeah, 250. D point is what?
0, 200.
0, 200. And what is the value there?
400.
400. So maximum here.
Yeah, and minimum is along the line AB.
Minimum is what? Okay, these 2 points, right? So
No,
what
sir.
it is?
No, sir. It's not only those two. It's
Okay.
every point on the
Every
line
point
side.
here.
Yeah.
Every point will give this only. Yeah, guys, tell me. Every single point there will give us what? Same value only, right? Okay. So any point over this AB will give us this what we can say or what? Tell me, guys.
Because the equation of the line is x plus 2y is equal to 100.
Yes, because for any point here over this line, we'll get 100 only, right? Above this more than 100, but over this line 100 only. So any point on AB line segment, right? Okay, AB line segment. Right, okay, this is what we have. Minimum is what this is what minimum here. Is everyone getting it? Tell me. Wait, if you want, okay. Just cross check your answer, guys. Does it make sense to everyone? So maximum is what? 0,200 and minimum set is 100 at B and also at point P, right? Okay. Or any other point on this line segment also we can say. Clear? This is how we are going to give the answer for this. Got it, guys? Clear, no?
Yes, sir.
Yeah. Okay. Now there are few fill in the blanks questions we can have. The function which has to be maximized or minimized in a LPP is called as objective function, right? It was like blank there, and then they're asking, right, what it is called as objective function. The common region determined by all the linear constraints of a linear LPP problem is called as what?
Feasible region.
Feasible region, right? Okay. The minimum value of the objective function in a LPP always occur at one corner point of the feasible region. Straight, true or false?
False.
It is false. Okay, everyone is getting that? Guys, what they're telling, the minimum value of objective function, any objective function in a LPP always occur at one corner point of feasible region. It looks like true, but just now only we got what? It can be on any point. Okay, only one point is not there, right? So remember, it is false. We can see from this question only, right? 2 points. It can be a line too, right? Okay, one more question. In a LPP, the objective function is always in a LPP, the objective function is always linear, quadratic, cubic. It will be always linear, right? Remember that. Okay, it will be linear. Then in a LPP, the inequality or restrictions on the variables is called as constraints, right? Very easy. If the feasible region in a LPP is unbound, okay, listen here. Okay, you can note down this point if you want. If a feasible region for a LPP, if a feasible region for a LPP is unbound, then the optimal value of the objective function
May not be possible.
may or may not exist. Very, very important point. This is what the point I was talking about. Okay, note it down. Okay,
Because
guys,
if it's unbounded, like positively,
correct.
then we're asked to maximize it, you can't find the answer because it's infinity technically.
Yeah, we'll discuss one question. Okay, I think in NCERT book only it is given. We'll discuss one question related to it. Okay, so write down everyone. If the feasible region of if the feasible region of for a LPP is, if it is bounded, then it will be what? Always, right? What we will get? We will have minimum or maximum, right? Are you getting me, everyone? Optimal solution will have, optimal value will have if it is bounded. But if it is unbound, so this is what they fill in the blank. Okay, unbound, right? Okay, if it is unbound, then optimal solution may or may not. Have you seen the question or not? This type of question may not exist. Tell me, guys, have you seen the question like that or not? It always extreme, right? Okay, yeah. Yes, in NCERT book, okay, wait, should I show you this right? I think we have. Okay, here also this point will be there, right? Okay, what it is in theorems it is written. This is what from NCERT only, that okay, these points are mentioned here also, right? What we are saying, let R be the feasible region. If R is bounded, then objective function Z has both maximum and minimum value of R, and each of these occurs at the corner point or like corner point of R, right? Okay, or like any point of like there on the line segment also. Feasible region R is unbounded, then maximum or a minimum value of objective function may or may not exist. However, if it exists, it must occur at a corner point only, right? Okay, that is what they're saying. Then multiple, okay. Right.
Sir, but it can also happen on the line joining the two corner
Yeah,
points.
yeah, right. Where is that example? Okay, right. Okay, which we discussed, I think.
So line, it won't be possible,
Yes, sir.
right?
Yeah.
The line segment, because it's unbounded, sir.
No. Bounded we are talking.
No,
Acha,
unbounded.
So
Minimization.
unbounded.
Minimization, and then if it's the same as equation, it can happen.
Okay, wait. I'll
That's
take the
bound.
example. No, I don't think it is here. Okay.
So it went above, like,
Here, this one.
no, sir, this graph only.
Yes, sir. Yeah.
This is what this example only, right?
Yeah. So you didn't believe me when I said that.
Yeah,
There are multiple solutions. Sir.
right. Okay. So guys, here, this is what it is. This is what the problem, okay, and we are getting objective function like that, and constraints are like this, okay, from here. So we made the graphs, right? Okay, now what is happening here? This region is coming, feasible region is coming, what? Unbound. Okay, it is like this here, correct? Now what happens here? Okay, what we are going to do here, okay, now so we check the values at these points, right? Okay, these are the corner points here, these corner points here. So what we get the values here, 7/20, and then what? Wait a minute. Yeah, there are 2 points, okay, here 160 we are getting. I'm forgetting the question, okay, don't remember it now. Okay, everyone try to do this question. Can you see this? Okay, do it now, everyone. Try it once, okay, like, okay, you will understand this. What they are telling now, determine the minimum cost of the mixture. Are you guys sure that this is what the same question? It doesn't exist, or what? What happens here? I'm looking for the example in which it doesn't exist.
No, sir, not this one then.
Not this one, right? Okay,
Not
it
the
was there.
question, the graph, right?
It was in CBSE book only, right? Okay, in NCERT book only, right? Okay, it was there, I think.
Sure, but in this, maximum doesn't exist because it's unbounded, right?
Yeah, maximum to infinite, right? Kind of like that it is.
Sir, I think
Maximum
maybe
won't
a
be there.
graph.
Sorry?
So maybe in a different chapter, sir.
No. In this only, right? Okay, we have seen that. Okay, when it doesn't exist. Okay, 1 second. I'll take that. Okay, I think.
No, sir. I'm saying you might have written it in a different chapter.
Chapter, right? Okay. No, I remember it. Okay, it was there in the PDF. In that PDF, I did. Okay, NCERT PDF book. Right, in the book itself, I explained. Okay, I didn't do here separately. Okay, 1 second. I'll take that. Okay, no problem. Before that, okay.
Oh, sir, then maybe you're solving on the PDF of that.
Yes.
Not on
Yeah,
OneNote.
that's what it is done.
No,
Okay,
not
guys.
on
So,
OneNote.
yeah, not in OneNote. Okay, we didn't write there. Okay, one more objective question. Okay, everyone, listen here. Let's discuss few questions. Okay, And then, okay, this question is there. Okay, let me just explain this question first. I'll be taking that question also, but later on. Where is it? Webinar here. Yes. Okay, question is corner points of feasible region for the LPP are 0, 2, 3, 0. These are the corners. Okay, 0, 2, 3, 0, 6, 0, 6, 8, and 0, 5. These are the corner points of the feasible region, right? I'm not writing full theory part. Okay, right? Now what they're telling, f is equals to 4x plus 6y. 4x plus 6y be the objective function. This is what our objective function, right? Then minimum value of f occurs at what? Minimum value of f occurs at what point? Occurs at, then options are given. A, B, C. Should I write the options or you want to give the answer without options? I think you can give, right, without options also. Do it, everyone. Yeah, is it done? Very good. Okay. 1 second. Okay, Parth, right, okay. That is one option, but what you are saying, that is one option. And it is written. Parth is saying that, and then, okay, Latika, there is no option like that. But what is the option given? Okay, wait, I'll tell you that. Okay, right. I know you all are giving two answers, and Parth is giving just one answer, one corner. Mithini is giving one answer only. Yeah, they are saying, okay, they have written 4 options. 0, 2 only. Then B option is what? 3, 0 only. C option is what? The midpoint of the line segment joining the point 0, 2 and 3, 0 only. D option is given that any point on the line segment joining the points 0, 2 and 3, 0. So D option, again, what I'm trying to say, okay, listen here, everyone. You will, first option is written 0, 2 only. Second option is 3, 0 only, right? And like by chance, okay, someone is in hurry and then he will say, right, sir, I did it correctly. I found it and I gave this answer, right? But you didn't read the last option, right? That is what given, right? So line segment, which is what joining 0,2 and 3,0. That is what the answer, right? This is not the correct answer. So remember this, right? Are you getting it? Okay, Latika. Yeah, I got it. I got it. I wanted to just tell you, right? Okay. So be careful about these type of options. I know question is very easy, right? You need to just put the values and you can figure it out, right? But in choosing answer, right? Okay, you can do mistakes. So just be careful for that part, right? Okay, that's it. Okay. I found that question, okay, which I was looking for. We'll do that. Everyone understand, no? Right? Any doubt, anyone? Abhinraj, tell me. Got it, no, everyone?
Yes, sir.
Yeah. Clear, right? Okay. Now question is, okay, there is one more question. Okay, same question only. They are saying here maximum of f minus minimum of f will be how much? What is maximum minus minimum of this above question only? I think that is also not that difficult. Okay, you all can answer. Sir, points, please. Lahari, I didn't get you. What?
So just scroll up.
Sir, can you please scroll
Acha,
up?
acha, sorry. Okay, fine. Okay, is it done? Yeah, right. Okay, one second. I'll check the answer for that. Okay. Yeah, right. Latika, what? You're getting different answer from others. Shivam, you're getting different answer? No. Bhumi, Devashish, Mrithini, Abhinraj, they got it right. Okay. Varun, silly mistakes. Latika, silly mistake is there. Shivam, silly mistake is there. Right. Lahari, correct. Okay. Answer should be what? Tell me, guys, what should be the answer? 60. 60, right? Okay, that is what the answer, right, Abhinraj. Okay, just check that, right? Okay, I think you can get that. Okay. Now this question, this is also easy, right? You can answer. Okay, done. Okay. It is 6 and 0, right? Yeah. Then 6 and 8. 6, 0, 6, 8, right? Like that. Okay, fine. Chalo, no problem. You can do, right? Okay, that one. Now here, question number, this one, right? Okay. Which do not lie. Sometimes we do mistake in this type of question also. We really forget, okay, which do not lie. Okay, so underline that and then do this. Okay, so which point is not coming? Right, we'll just satisfy, right? Okay, that is very easy. Okay, now let me just show you. Is it done? Which option? C is coming or not? Tell me. which is not lying in this, right? 4 and then 9, which is becoming what? 13. Wait. Yeah, it's satisfying, right? Do not satisfy which answer? Did I do
Sir,
any
all the
mistake?
points are satisfying.
All are
Yes, sir.
satisfying, right? Okay. Then I think I did some plus minus change.
So that
Wait.
-3 too, sir.
It is 2,3 minus 3,2. All are satisfying, right?
Yes, sir.
Oh my God. Okay, it is 0. That's what the mistake. Now do the question, guys. Sorry. So I think C is the answer, right? Okay, you can easily identify. But again, what could be the mistake? Okay, sometime we forget that it was do not, right? Okay, that's it. Okay, let me show you that question which I'm talking about. Okay, this one. Yes, okay, this is right. Okay, here. Can you see this question, guys? Okay, everyone. This is what it is, that determine the minimum value of z is equals to 3x plus 2y if any. Why it is written if any? Because it may or may not exist for unbound only, right? Okay, if the feasible region of LPP is shown in this figure, right? Okay, 12.2, right? The figure which is what there down, right? This one. So this is what feasible region is what coming like this side. Getting it, everyone? This is what we have feasible region here. One second, guys. Okay, just open where I can edit it. Yes, give me one. Right, this is the question I'm talking about. If, right, okay, what they're saying that if it is any point here, like this. So these are the points, right, we have, okay, for this unbound curve here, right, unbound feasible region, right? These are the points, okay. It may or may not, right? Okay, may or may not, minimum or maximum also, right? Both, right? Maximum though, right? Okay, maximum though it will be there, right? Okay, what? Infinite, because we can take maximum to no question, right? Okay, see here, if it is unbound, what? Some value infinite, right? If I put that, okay, what we will get? Right? Are you getting it, everyone? Maximum also that if they're putting like, okay, minimum value they want to make it, okay, right? Maximum to infinite because it is unbound, so we can reach to infinity, right? So that time maximum value will be what? Infinite only, right? So that's the smallest may or may not exist, right? Okay, like that it is here. That's why they're using the word. If it is bounded, it will be always, if it is bounded curve, it will be always minimum and maximum a value will exist. But for unbound, see here what they're writing here, this you should understand that, okay, this is what it is. Open, okay, this one. So where is the point? Okay, unbound ke liye. Yeah, this region is unbound, therefore minimum value may or may not exist. If it exists, it will be at one corner, like that it is. Correct. Now I think there was one more question in which we do not get the minimum value also, right? Like we don't get only for unbound only again. I think there was one question. Okay, yes. Is it there? This is bounded or what? Okay, the determine. So just go through these questions. If you have any difficulty, okay, you can ask. Okay, now these type of objective questions, this is from NCERT exemplar only. So do these all questions, guys. Okay, this question now, the corner points of the feasible region are given like that. Now this is what there. So we need to find out like what this question can be done. Everyone can do condition on P and Q so that maximum of Z occurs at this value, right? Easily we can put, right, okay, this one here, right? We will put the values here and then Is everyone getting it or not? Tell me. Anyone has doubt here? The corner points of the feasible region determined by the system of linear equation by the linear constraints are these, right? That this, okay, P and Q both are positive, right? Constraint P and Q that maximize occurs in this at this point and this, right? So the correct answer, since Z occurs maximum at this and this, both the points, right? Okay, we are getting, so both will be equal or not? Tell me everyone. Both are equal maximum. So then we are giving this relation. Any confusion in this type of question? You can do, no, right? Okay, sometimes questions will be there like this. So everyone should be able to answer it. Okay. Now, yeah, right. Okay, this one here. This is the question again for unbound one. Feasible region shaded, okay, here is shown in this. Minimum value occurs at which point, right? Okay, one of the point. Okay, so here though, I think answer we are getting these 4 points are there. B is the answer. Okay, fine. So this is not that. Then true false questions we already discussed. Okay. Still not getting that done. That question in which it doesn't exist also, right? Okay, there could be. And now, okay, here we have diet plan question or manufacturing question, 2 types of question. Transportation question could also be there. So should I explain that? I think that is not there in the portion, or it is there. Can anyone confirm?
Sir, in the NCERT textbook, only the first exercise was there.
Okay, fine then, fine.
So the applications of LPP is not there, I guess.
Oh, application is not there. So that means that whole portion is gone, right? Okay, like manufacturing and diet plan, that whole thing is gone.
I
Yes,
guess so,
sir.
sir.
Yeah.
So they can't ask for 1 mark this much, no?
Yeah, correct. Yeah. No, I thought, okay, if they are making paragraph and that case study type of question from this, okay, that's fine. Okay, so guys, do all these questions, okay, from this NCERT exemplar, okay, right? I think that will be more than sufficient, okay, this first part only, right? Okay, these NCERT exemplar questions, right? That should be more than enough, right? See, I asked this question only, right? Okay, so it is from here. Okay, fine, then we'll move on to, right? That's what we have in LPP, right? Now, can we do this remaining part of what? Okay, our applications of derivatives. Is it okay? Okay, sir, bye. No, we'll do derivative part. Can you explain when the minimum doesn't exist for the unbound region, like how to check it? Okay, 1 second. I'll take with the example only, I'll explain. Okay, so I'll check that. Okay, let me give you one question based on, 1 second. I think it was there. I've seen that question, but I don't know. I'm not able to figure it out. Okay. Jyoti, can you search for that question in which it was there?
Oh, yeah, sure.
It doesn't exist only, right? That one I'm looking for.
That's what happens when you search for it, sir.
Sorry?
Whenever you search for something, you don't find it.
Yeah, search it fast now. You search it. Let's see if you'll be finding or not. Okay. This is what? Okay, we need to do what? Applications of derivatives. Where is AOD? Methods, yes, here in this. Okay, so we did what already? We have done increasing, decreasing. Any doubt in increasing, decreasing? We can do that, right? Okay, applications of derivatives, we have done increasing, decreasing. We need to differentiate and we need to check the sign of derivative, whether it is positive or negative in particular interval, right? So I hope there is no doubt in this. Tell me. In this last question, okay, that trigonometric one, okay, right? I hope everyone understand that. We were getting more than, in the option, some different answer was given, but we were getting 2 points where it was becoming 0. So it was positive for this 0 to pi by 4, then pi by 4 to 7 pi by 12, and then up to pi, right? Like that. Now let's do what? Okay, we need to do now maxima, minima. That is also very easy, right? Okay, what we will do, let's do the maxima or minima. Right. So in this, what we are going to do that we need to find out whether it is maximum value, where does the maximum value and minimum value occurs. Again, we can use this what concept we learned above. Okay, using that we can find out. Okay, so guys, graph could be like this. Now there will be things here that, okay, one second. Suppose it is this one. You know, this value is what? It is called as local maxima. Why it is local maxima? Because it is greater than the nearby values, right? It is greater than the nearby values. Locally, it is greater, right? Locally, it is maximum. From this side, from left side, from right side, it is what? More value. And this is called as local minima. Local minima and local maxima, right? Local maximum, local minimum. But if you talk about what is the maximum value of this function, suppose this is what example of this function, x minus x cube minus x square, or sorry, no, x, right? Okay, it is. So if I take x common, I'm getting what? X square minus 1, and I can factorize it x plus 1, x minus 1. So you can see this is what minus 1 here, this is 1, and this is what 0, right? So it is what? Maximum locally here, but what is the absolute maximum value, or what is the maximum value of this function, where it will occur? At infinity, right? It will go to infinity, at infinity here. Minimum value at minus infinity, because it is going down here like this. Getting it, everyone? So there is a difference between local maximum, local minimum, and what? Between absolute maximum, or just they say maximum value. So this is what you need to remember. Getting it? Now there are like two methods. First derivative method. We have first method, what? First derivative method. And then we have second double derivative, right? Okay, we call it, okay, double derivative method. Right. In first derivative, we'll just differentiate once and we will check. We will check in what interval it is becoming positive and negative, right? So like if I take the example, same question, right? F dash of x, it will be becoming what? 3x square minus 1, right here. Now, what I can take 3 common, and it is what? X square minus 1 by 3. Then we are getting here x plus 1 by root 3 and what? X minus 1 by root 3. So now guys, okay, what we have here, we can decide. There are two critical points here, right? 1 by root minus 1 by root 3 and 1 by root 3. Correct, everyone? So this derivative, right? First derivative, dy by dx is what? Before, see, you can use Wavika method, or you just put any value which is what? Greater than 1 by root 3. So if you put any value greater than 1 by root 3, this bracket will be positive. And this will be obviously positive because you're putting positive value plus positive value. It will be positive. This will also be positive because you're putting a value greater than 1 by root 3. So that's why it is positive here. Then if you put in between value, this will be negative and this is positive. So negative positive is what? Negative itself, right? And then positive here because both of them will be negative here. Correct? So what we are saying, the derivative dy by dx is what? Greater than 0 before 1 by root 3, and that is what here? 1 minus 1 by root 3. Before minus 1 by root 3, it is what? Positive. Derivative is positive, means graph was increasing. Are you getting it, everyone? Dy by dx is what? Greater than 0. Then dy by dx is becoming what? Negative. And after, at this point, which is what? 1 by root 3. Right, positive 1 by root 3. Graph is what? Negative here. Sorry, slope is what? Negative. Slope is what? Negative, and then slope is becoming positive. right? You can understand from this also that tangent is making what? Acute angle with the positive direction of x-axis. So it is what? Positive slope. So when as, okay, what we will say as graph is changing from positive to negative. So this is what our point of maxima or minima? Point of, are you getting me, everyone? This is point of maxima, right? Because what happened? Okay, graph was increasing, then it started decreasing, right? Okay, so that's why maximum value happened. Okay, there, point of maxima, local maxima, you can say, right? Okay, then this is what point of minima. Is everyone understanding this? Very simple or not? Tell me. By derivative method, first derivative method, we can do this way. Clear? Very easy, right? Okay, we'll see the questions. So that's why I'm covering theory part. Okay, right? Okay, like this. Suppose they ask for absolute maxima, absolute minima for this type of question only. So we'll find out local maxima, local minima, and then we will figure out what is the values out at those points, right? And then we will see that it is what? Never ending, or if they're giving some interval, let's say they're saying that, okay, -5 to +5, you check, right? -5 to +5 in this interval only need to check. -5 to 5, what is maximum value and what is minimum value? So at those boundaries also we will check the values. At -5, what is the value of the function? At +5, what is the value of the function? And then we will give the answer. Whichever is the value maximum out of these two values, we will find out f of -5, we will find out f of 5. And whichever is the maximum value out of these, okay, that is what our maxima. Because we know this is what maxima, right? Okay, so we can decide easily. Is everyone getting it or not? Right? This whole picture, what is happening? Right? We'll see the question. Okay, no problem. Now, when I come to double derivative, we'll find out first derivative method. Here, we will do that. We'll find out critical points. We will find out critical points. Let's say x values are C1, C2, C3. At these points, f of x is 0 for these all values, let's say, right? At these values. Now, find out double derivative, and put these values here, right? We will put the, now check the sign of f double dash of C1. If it is negative, that means what? If double derivative is what? Negative. If d2 y by dx square is negative, what does it say, guys? Maximum. Negative means what? Graph is what? Concave down. Like, I don't know what do you call it. Okay, concave down or convex graph. Okay, whatever it is, but it'll be like this. So there we will call it is what? It is maximum. It is a maxima, right? If it is positive, if d2y upon dx square is positive, then it will be like this graph, which is what? Minima, right? It is what? Minimum. That's it. Got it. So let me show you the questions. Okay, let me take few questions for this. Right, we have time, no? Okay, good. Okay, everyone answer this question. Find the maximum and minimum value, if any, for the function minimum and maximum value, if any, right, for the function sine of 4x plus 3, and mod is also written here. Now, which method you will use? Here, no need of using derivative and all, right? We can give the answer directly. Tell me. We can give the answer directly or not for this? What will be the answer, guys? Maximum and minimum value for this? Everyone knows. It could be like this also, sine of x plus cos of x plus 3. What will be the answer, guys, here? Minimum and maximum. Nobody's giving answer. Oh, sorry. Oh, okay, my bad. Okay, I didn't see the chat. Sorry, guys. It was hiding actually. Okay. Minimum is what?
So 2.
No. Yeah, right. Okay, Devashi's correct answer. Oh, Lari, maximum is 3. Why?
Maximum 4, sir.
Maximum is 4. Lari. For first question, right? For A part. Right, okay. Yeah, everyone is getting that. Minimum is 2. Maximum is 4. Right? How we do that? We know already sine of 4x is always going to lie between what? -1 to 1. Then plus 3, we will do both side, right? Plus 3. Right? So then we are putting mod, but it is already positive, so it is not going to change, right? Okay, that's it, right? Okay, here. What about this? Wait, Vedant, are you sure? Wait, what is the answer for this? Why many of you are not giving correct answer? Yes, now correct answers are coming. Devashish, Prithvi, very good. Yeah, now correct answers are coming. Yeah, Prakhar, very good. Maximum value, that is minimum value. Vedant, what is that? Maximum is 5, minimum is 1. So much wrong. Right? That is like so much wrong. Okay, I don't know. Like, okay. Abhinraj, which question are you answering? Are you answering A part still?
Actually, no, sir. Second part.
That is so much wrong answer. Okay, seem like Vedant. Bhumi, wrong answer. Oh my God. I thought I just changed the question. I just modified. I don't know. It came to my mind. Okay. And I created the question, but why are you making it so? I thought everyone will answer this. I just asked for, okay, Jyoti. Bahut hi ganda answer. Okay, it looks like multiplication sign. Oh my God. Wait. Tum log na. I'm writing fast, guys. Okay.
Sir,
It is
was
plus.
not-
Okay, now give the answer. It is plus here. Now give the answer.
No, so like the problem is when sine is minimum, cos will not be minimum. No, so everyone's
Ah,
meeting
so
same.
what do we do?
Yeah, but you have
Very
to find
good.
the minimum of the combination.
Very good, very good. Like now in 12th grade, we are realizing that, okay, right? Sine is minimum, cos is maximum, right? They're not
Sir.
like they have fight with each other, right? So what to do, sir? Right? How do we find out the answer? They're
Sir.
fighting with each other, correct?
So the question
Very
is sin
funny.
x. So sin x
Vedant.
plus cos x plus 3, right?
Yeah, 1 second. Yeah, plus 3. Plus sign is there.
So that
Vedant,
plus
now in
is
12th
always
grade, we
looking
are
like a
trying for this
multiplication.
thing, right?
So
Oh my
that
God.
plus has always been looking like multiplication, sir.
Okay, now answer it. Okay, fine. Now answer it. I corrected it. Yes, Sriniketan, correct answer. Mithi, wrong answer. Yes, Larry, correct. Maximum value is correct. Guys, maximum value is what? Tell me. Abhinraj, now tell me the answer. Okay,
So 3.
wrong answer then. That's what I'm saying. Okay, you guys were
So 4, right?
wrong. Maximum value is 3 plus root 2 in 12th grade. Also, we are not realizing it. Okay, now why, guys? Minimum value is what?
So 2 and 5, right?
Very good. Smart boy. Note down this. Okay, minimum value is 3 plus root 2 and minimum maximum value is 3
So you
plus
can
root
have
2
2
and
if you
minimum
put it as
value is
pi.
what? 3 minus root 2.
So if you put it as pi, then it can be minus 1 and
Wait,
0, right?
Jyoti. Wait. Guys, what do we do here? We cannot decide, right? Like Vedant is saying, one is giving maximum, one is giving minimum. We need to combine, we need to use, right? Okay, some logic to combine them, right? Okay, that's how we decide. So what do we do for that? Multiplier is what? 1 here, here also 1. So we do here 1 by root 2 here, sine x plus 1 by root 2 cos x. I think I did it multiple times. Okay, then also Vedant, why you are not able to answer it? Can I do this modification, right? And now what is it forming here? This is becoming what? Sine of x plus 45 or pi by 4, right? Can I say that? Tell me, guys. Now it is changed to above format only, right? Like this here. So what is the answer now here? This is what, tell me, can we do this or not?
Yes, sir.
What, we are not doing this or what? It is like domain range, range question from 11th grade. Got it now, everyone now?
Yes, sir.
Right. This is what -1 and maximum minimum. So root 2 is multiplied. So minimum is minus root 2 and maximum is root 2 plus 3 is added. So that's how it is, right? Okay. Jyoti, did we not do this? Okay. Before you're going to argue on this now. Did we not discuss this? Did we not do multiple times? I think we used it. Okay. In other questions also, right? Okay. This
Can't
concept.
we just replace x as pi?
Next question.
-1 plus
Let
0
me not discuss this anymore.
plus 3. So it's going to
I'm
be
not talking to you.
Sir, why? Sir, if it's pi, then it's 2. I just replaced values and found them.
We'll talk separately. Okay. Think about it later. Only you can reply. Okay. And we'll talk later. Okay. Let's do this. Okay, guys. What they're telling, they are saying here, for this function, find the absolute minimum and absolute maximum, guys. Find the absolute maximum and absolute maximum and absolute, and tell me plus minus. Okay, now only if anyone is having confusion. I'm writing fast. Okay, I want to do maximum questions, right? Okay, so that's why it's sometime. Okay, plus multiplication, it looks like. Lahari, what? I didn't get you. What are you saying? Okay, wait, interval is given. In the interval, guys, in the interval is also given here. Sorry, yeah, this is what it is. In this interval, we need to find out the maximum, absolute maximum, and or they can say like maximum and minimum value for this, not local. Do it fast, everyone. Yeah, guys, options are given. If you want, I'll give you the option for this question, but if you can give without options, okay. Maximum value we need to find out here for this. It is x into x minus 1 plus 1 whole power 1 by 3. Yes. Okay, give the answer for both the questions. Give me 1 minute. Okay, I just want to look for that question. Okay, wait. LPP is what in the first part of your book or second part? Any idea, guys?
So the second part.
Okay, second part, which question, chapter number exactly?
I think it's 11. I'm not sure, sir.
Okay.
No, so it's 12.
Okay, 12th. Okay, fine. Thank you. Let's just stop. Okay. For first question, okay, everyone is getting the answer. Okay, what is the answer you got for this one? Okay, minimum value and maximum value, absolute one, right? Absolute one we are looking for. So minimum value is what? Yes, Bhumi, very good. Perfect answer, right? Minimum value is 24 and maximum value is what? Absolute maximum value is what? 56. Yeah, Prithvi, exactly. Same. Lahari, you did some mistake. Okay, just cross check that, right? Okay, then yeah, Devashish got the answer. Then Sriniketan, Lahari didn't get. Okay, right. Okay, who? Prithvi got it, right? Okay, Prithvi got it. Then Bhumi, Sriniketan, then yeah, that's it.
So what is the maximum value?
56. Absolute maximum.
So I got 153.
Mrithni, what is that? What do you mean by that, Mrithni? I didn't get you. What Mrithni is saying? Guys, yeah, why we are doing mistakes like this? Mrithni, you are saying that minimum value at 1 and maximum value at 5, like that? No, that is wrong. Okay.
No, sir, but if you put the values, you're getting what you are saying.
Sorry, what?
If you put 1, you will get 24 as the value. And if you put 5, like she's saying the point.
The
Okay.
points.
Okay, fine. Okay, so it might happen, but it is not always true that, okay, at the lower value, we will get minimum and at the maximum value, we'll get always maximum, right? Okay, like that. It is not. It is true for linear function, but not for every function like that, right? I'm trying to explain that because Mrithini, what answers you gave? Okay, is 256 and minimum is what? 28. So I think when you are substituting, you are doing mistake there. No, I checked for all. Okay, fine. Why then? If you checked it okay properly, then it should be like, I think you're doing some mistake then. Okay, we'll find out f dash of x. So what is it coming, guys? 6x square, right? 6x square minus 30x, right? Minus 30x plus what? 36. 6 can be taken out common. X square minus 5x plus 6. It can be factorized easily, right? Okay, x minus 2 and x minus 3, right? So we have, what are the points we have? 1, 2, 3, and 5. We should check the values at these points, right? Tell me, everyone. Correct. So at 1, what we are getting? 24, is it? Maybe, right? Okay, yeah, 24 it is coming. Vedant, that's what you're saying?
Yes, sir.
2, then minus 13. Yeah, minus 12. Yeah, 24, right? Okay. F of 1 is what? 24. Then we need to check at 2 also, right? F of 2 is what? Okay, Mrithini, you wrote 28, so that's why I think that is what? Plus minus mistake. Okay,
29 f of 2.
29. Okay, F of 3.
That is 28.
28. F of 5.
56.
56. Okay, so see, sometime what we do, okay, we don't realize, okay, we are just finding maximum minima. So that we differentiate, we find out these 2 points and we feel, okay, this is what maximum value, this is what minimum value, but that is not that is local maximum, local minima, right? But they are saying, when they say maximum and minimum in this interval, so even if absolute is not written, you need to understand that they are looking for absolute only, right? In this interval, maximum and minimum is what? Minimum is this and maximum is this. Are you getting it, guys? So these are the answers. Tell me. Right now? Okay, yes, Prithvi. Yeah, tell me.
So, but if we put 4, we are getting like a higher value than 5.
Seriously?
Yes.
No, not possible.
So you can't.
Good. Wait, what it is becoming?
Okay,
4.
sorry. My
Yeah,
mistake.
you're doing some mistake. This is not possible, right? Dekho, polynomial graph is there. Polynomial graph will be like this only, right? It is going like this. Okay, local maximum happened somewhere, local minimum happened. Okay, before this it will be going down only. It is not like suddenly jump karega, right? Okay, polynomial
Yes,
graph it will be always continuous, right? Okay, so that's not possible, right? Okay. Fine. Yeah, next question answer, which one was it? Okay, yes. Right. Okay, Prithvi, you got the answer, right? What did I ask? Maximum value. The maximum value of this is what? Yes. So what is the maximum value? Exactly, right? Okay. Larry, what is the final answer? Maximum value is what?
So it's 1 at 0 and 1.
Yeah, but you are saying minimum value is what? 24?
So that was for the third question. So actually I said it.
Okay. Sorry. Yeah, I didn't see that. Okay, right. Correct that. Yeah, maximum value is what? 1, right? Everyone is getting that right. Prithvi, Vedant, yeah, you got it right. Okay. And yeah, what about others? Yeah, Larry got it. Okay. Abhin Raj, understanding or not?
Yes, sir.
Okay. Varun, getting it or not, right? Okay, these things we need to understand this way, right? Okay, that is what it is, right? Okay, done, I think. Okay, let me just cross check. I downloaded the book. Okay, LPP. Okay, now in this, if I have, okay. Yes, okay, let me give one more question. Okay, tangent normal, any difficulties there in that? Tangent normal. Tangent is what? Okay, tangent is what? Slope dy by dx we are going to use. You need to remember line equation forms, right? we'll be using maximum times, we'll be using what? 1-point slope form, right? So tangent, okay, let me just briefly tell you the concept. Okay, guys, you need to wait for some time. I'm just looking for that question where it doesn't exist also sometime, right? That value. Okay, what it is, tangent and normal, right? So, okay, let me just briefly tell you here on the right applications of derivatives. Here we did tangent. Okay. I think first lecture was this only, tangent and normal. Okay. So what we do here, equation of tangent is going to be what? 1-point slope form, right? Okay. Everyone understand this? Can you see my screen? These notes? Okay. This one here, y minus y1, at some point they will ask, right? Okay, tangent. So we will find out the slope at that point by the given point. Okay, we can find out the slope at that dy by dx value at that point, right? And we'll use this equation, right? Normal will be what? Just perpendicular to that. So minus 1 by m form, right? Okay. Now this question, find the point on the interval this at which tangent is parallel to x-axis. So when tangent is parallel to x-axis, slope will be 0. So we need to find the points where slope is becoming 0. So actually what we are doing, dy by dx equals to 0 we are putting, and that's all, right? Okay. So question is asked, okay, where maximum minima is happening, like that. Okay, right? They're trying to ask same question, right? Somewhat similar, right? So we'll get the points like that. Okay, Jyoti chala gaya kya? Okay, fine. Equation of the tangent to the curve, this curve at point where it crosses y-axis. There are questions like this. Okay, so because tangent normal, basic questions will be like dy by dx, you find out and all like that. But what it will be? Equation of the tangent to the curve, this curve at the point where it crosses y-axis. Crosses y-axis where? What? X will be 0 right there, and y will be some point, right? So that is where, like, x you will put 0, so y you can find out from here, and then that's how you are getting the point. So sometimes they can make a question kind of difficult or tricky this way. Everyone is getting that or not? Tell me. Everyone can do this type of questions? Tangent and normal, easy. Done. If any doubt is there, let me know, right? Okay, just go through these examples. These are like good questions here. Wait, I'll just minimize it. If any doubt is there, you can see the example below also, right? I think I know I discussed in regular classes only this, but time is not there. That's why I'm just finishing it, okay, like that. Okay, yeah, someone was saying, sir, can you show that question in which it doesn't exist? Let me see if I can figure out that right away. If I'm able to find out, I think I've seen in NCERT book only that question. Yes, I believe. Okay. Okay, see here, everyone. Can you see? Let me show the screen. Okay. 1 second, guys. Okay, just 1 minute. Okay, that's it, right? Okay, it will be done. Within time only we'll finish. Okay, good. Where to maximize it? What happened to this? Okay. What is wrong with this? Okay, can you see this question, guys? Okay, what they're telling. Everyone see here. Print screen. It is coming in print screen. Yes, can you see this? Cancel.
So actually, we can see your PDF. Actually, you have shared the entire screen.
Acha, okay, I shared it here. This one, right? Okay, yeah, you can see this. No, actually, I wanted to show this screen. Wait, I downloaded it. Okay, 1 second. Okay, fine. See here. This unbound graph is there, guys. Okay, here. This down one here. You see, this is the example which I wanted to show, right? For that. See here, determine graphically the minimum value of the objective function this. So when we graph it, okay, we are getting unbound graph. Everyone is seeing this. This is what final. This is what final unbound graph. Okay, common for all the conditions. Can you see it, everyone? Right. Now what happens? The feasible region is what? Unbound. So what we do here at the corner points, we are finding the value and smallest value is happening at this point. But is this the minimum value? Right. Okay, we are going to see that. Right. So what we do actually, we look for one more point. Okay, see here. So from this table, we see this is what smallest value, right? Can we say minimum value is this, right? Now what? Not that the, okay, this is what this graph is available further also. So we will see one more point. Okay, we will observe there. So what we see here, but here we see that feasible region is unbound. Therefore, minus 300 may or may not be the minimum value. To decide the this issue, we graph the inequality. Okay, this inequality is there. No, which inequality is there? This one. We will graph this. Okay, yes, this is the method. Okay, which inequality we are going to graph? This is there, no, guys. Okay, this one. This minimum function only. Everyone understand this? If you didn't see this before, okay, see it now. 2y. Is this can be less than minus 300? We want to check that. Everyone is getting me this? Okay. What we are going to see, objective function only, we are going to put less than minus 300. Now, if we simplify, we are getting this and we are graphing it. Okay. This is what dotted line. Okay. Actually, this full was feasible region. And this is what our dotted line, dotted inequality, this one. We are just checking this value. Can this objective function be less than minus 300 in this unbound graph or not? Right. We are just going to see that. Is everyone getting that? Right. So now what we observe, yes. Okay, great. So what we observe and check whether the resulting open plane has points in common with feasible region or not. So this inequality is having many common points or not, right? Okay, here. If it is coming something like this, okay, suppose this inequality was going to come like that. Then what? Then this will be the final answer. But what is happening now? This is what the inequality we are getting. This inequality, which is what we are saying that, okay, this objective function, this minimum value, can it be less than this? So we are getting this dotted line like that. And it is having many points actually like this, right? Many points are there which are satisfying, which are making it less than this, right? With feasible region, it is having many points in common. So that's why this is not the answer. There is no minimum value for this. That's what we say. We cannot say that this 6,0 is what minimum value for this. So it is what in your NCERT book only, guys. Okay, page number 512. Go through this example, okay, and understand this. Question could be there like this. Okay, this is what interesting question, and it is. I think this is what this part is there in the portion, right? So do this. Very good chances are there that question could be there from this. Everyone understand or not? Got it, guys? Right. Okay. Bye then. It is time now. Thank you very much for joining. Bye. Okay, Jyoti, you were there. You didn't find. I only found. Okay, and you were saying you will not. You never find.
Sir,
okay. Thank you, guys.
You just told.
All the best, guys. Bye. You now I proved it. You never find. Okay, I only found it.
Yes, sir.
Okay. Yeah.
I never find answers also, so I don't know why you're surprised.
Yeah. Okay. Chalo. But find the answers in the exam. Okay. I want to see full marks. Okay. Otherwise,
it's a bit hard.
Otherwise, we are going to have heated PTM. I'll talk to your mom. Okay.
So PTM is somewhat like a very common word to teachers.
Yeah. Right.
Like
what to do otherwise, right?
Weapon,
you guys. Yeah.
Like a last weapon.
Last weapon. Correct. Yeah.
Come on, sir.
Okay, sir. Don't have another PTM. I'll try getting.
I had one PTM in my 2 years. Okay, with Jyoti. Somehow I don't know how. Unluckily,
no, sir, you had 2 PTMs this year only, and then you had 2.
I had one only. I don't think 2.
No, sir,
Okay,
you are
chalo,
good.
koi nahi. We'll have
Okay,
2
bye,
or
sir.
more, okay, right now. Yeah, bye guys. Take care.
Thank you, sir. Bye,
Do
sir.
well, okay. All the best. Yeah, all the best, guys. Okay, be careful about the mistakes and all. Okay, silly mistakes. Don't repeat them, and remember the points. Right, highlight those keywords, note, and all sometime. Okay, those creates huge difference. Right. Okay. Okay, guys. All the best. Do your best. Give your best. Okay, in the exam. Bye. Hope to
Bye,
see
sir.
you again.
Thank you,
Okay,
sir.
no problem. Yeah. Thank you. Bye.